Alright, so for this last module, the inquiry activity I chose to look at is the photosynthesis in leaves lab. I have done this lab with students in the past, but I modified it to better meet the needs of a STEM lesson. So the driving question is, what important role do photosynthetic organisms play in the biosphere, and what is a way we can observe this process? So students get a handout. There includes a background reading, a procedure section, a data table, review questions, and then finally the application activity, which is geared towards the technology and engineering piece of the entire STEM lesson. The handout will be attached to this discussion post, so you can look at that. I'm not going to walk all the way through this procedure. I'm going to go to my next slide here, and this kind of walks you through the different steps. So you create a sodium bicarbonate solution with your students. It's literally just baking soda and water with a certain amount of grams within the water to get whatever percentage you want to use for however many classes you're doing this with or trials. You get a hole puncher and you punch leaf discs out using spinach leaves, and that's a picture of what they look like. Then you have to put the spinach leaf discs in a syringe and create a vacuum where you're taking out the oxygen from the spinach leaf discs and you're replacing them with carbon dioxide from the sodium bicarbonate solution. They will sink once that process is complete. You put 10 inside of the light cup and 10 inside of the control cup, which is your dark cup. All of the ones in the dark cup should remain sunken, and all of the ones in the light cup should eventually rise, which you can see in this last picture here, because they're going through their process of photosynthesis. And if you look closely, this is a lot easier to see in person, there's little oxygen gas bubbles next to the leaf discs, and that just indicates that they went through photosynthesis. For the data analysis section, students would be asked to graph their results after 20 minutes. So you can see here, ideally in the control cup, none of the spinach leaf discs would have risen, and after a certain time, all 10 of the leaf discs should rise in the light cup. The application activity is something new that I'm adding to this lab, so how can we further apply this activity to relate to a current issue? And that's a way that you can involve engineering and technology practices into the lesson. So discussing the importance of photosynthetic organisms and their role they play within the biosphere. So having that conversation with students that without these photosynthetic plants or other organisms, we would not be able to live or survive on the planet. And then pose them with threats that are currently impacting these species as well. So things like deforestation, habitat destruction, and urban sprawl. Have students pick one of those issues and then let them explore it more in a research type setting, and then have them use vocabulary to help provide evidence on a solution that can better help these plants or other organisms. So my alignment with STEM perspective, I believe that this is an entirely science-based lesson while incorporating technology, engineering, and mathematics. So the science behind it is just the phenomenon of photosynthesis. Math is the data analysis section where they have to collect evidence and data and then plot it in a line graph. And then the technology and engineering is just understanding how to follow a procedure and designing your different trials in the way that they do. And then the application activity that I discussed, and which is also in the handout. So assessing this lesson using the different tables from the Designing Meaningful STEM Lessons reading, students are asked to create a hypothesis. They collect and organize their data. They have to construct explanations using evidence in the handout. They need to communicate effectively in their small groups. They have to apply scientific vocabulary after conducting the investigation. So once they go through this lab, they start to get more familiar with the different vocabs surrounding photosynthesis, autotrophs, producers, things like that. And then they are asked to use computer technology in a logical manner to plot their own data. Using Table 6.3, teachers should relate content to the biosphere and challenge students' preconceptions. So having open discussions with students initially before doing this inquiry lab to open up that conversation of how do we get oxygen in the atmosphere and what cycles exist to help balance out those different gases. Engage students in learning through procedure and collecting data that definitely exist in this lab, and then introducing that science vocab once again after doing the inquiry activity. The two here that are in green are ones that I would better adapt or change to make this lesson more a STEM-based lesson. So maybe have it approached where students are the ones who are designing the experiment. So giving them the parameters and the materials that they can use, but then letting them come up with their own design would kind of match back to that technology and engineering piece. And then the assessment that focuses on problem solving, I would definitely try and improve that, where students are coming up with their own solutions instead of researching ones that already exist. So this was my STEM lesson to conclude Module 5. Thank you.